Hello, 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 ladies and gentlemen. Welcome back to what is it? Episode 7? Oh man, it's been a long season. But welcome back to another episode of the Tech Show. My name is Joel Sante, one of your co-hosts. I have my lovely colleagues here, and we are excited not only to actually walk you through a actual demo of a 3.2 web app, but actually discuss through the topics and the domains and the various different things we had discussed in a few weeks back. Uh, but before we even get to that, should we do a quick recap of the things we have covered in the past, 3, 4 weeks of a generic 3 tier web app and what encompasses of that? Does that work? Awesome.
Yeah, man.
Let's do that.
I think that sounds like a plan.
Let's do that. So, like we had said all the time when we started the 3 tier web app series, we said we want to make sure that individuals that want to get into architecting when it comes to just in the cloud in general and learn how to build various different things, a 3 tier web app is the best start for that. So what did we discuss when we started this process? We said the presentation layer is essentially the front end where you have your application being served to your customers. Then we said the back end is where all the logic is sort of held there. So any business logic processing, any data handling, any state management, that's where you would see that logic tier do that job. Then as of 2 weeks ago, we had the conversation about database. So where is your data being held? What database are you using? How is your data management being done? The data retrieval, the querying, all that stuff we discussed in last week. After the conversation, obviously, those were more theory. That gives you a overview of what a 3 tier web app and the various different tiers that comes with it. Today, we want to do a demo that illustrates and show you the details of maybe 1 or 2 different tiers, but gets you started with a 3 tier web app with some practicals. With that being said, we can kick it off and start the demo.
Yeah.
Absolutely. Let's do that.
Excited. Let's go.
So, with that being said, I'm going to pass it off to Danieska to quickly share his screen here. Then we're going to dive into what that 3 tier web app will look like, right? We said presentation layer, logic layer, all these extra things. What does it actually look like, and how do you actually start building these things? The reason why I want to build them is to help you get clarity when it comes to various different services that you might want to learn or use in your journey in the cloud. So let's get started.
Today, we're going to talk about a little bit about the network component of a 3 tier web app, right? And we're gonna do a demo. Okay. One more time.
No,
You're good.
you're good.
Okay. So can you hear me? Perfect. So this is the AWS landing page, and I want to talk a little bit about VPC before we start today. So we mentioned that before, that a VPC is a virtual LAN. So we have like different components, route tables, subnets, just like any other networking structure in any company. Now, a VPC, like I said, is a virtual LAN, it's a local area network in the cloud. So we'll be talking about how to deploy resources in AWS. But before we do anything with a 3 tier web app, we have to prepare the platform where we're going to deploy these resources. And that is a VPC, which stands for Virtual Private Cloud. Okay, so for those who don't know about the AWS console, this is it, right? So once you log in at aws.amazon.com or aws.amazon.com, that's the website. You log in, and then this is the landing page, and then you have multiple sections here. One of them is the recent visited services. In my case, is it has multiple services because I have visited these services before. But usually, when you open the account for the first time, you may not see any because it's a new account. It's a brand new account, right? Now, there are multiple ways to look for services, and this is one of them by seeing the recently visited ones services. And also here in the search bar, you can type VPC. Remember, stands for Virtual Private Cloud. We mentioned that before. And you click here, and it will take you to the VPC dashboard. Now, this is the area where we prepare the soil to start sowing. I would say to start deploying the resources for a 3-tier web app, right? So we have different components here. We have VPCs, NAT gateways, subnets. If you don't know about these concepts, I recommend probably going to YouTube, watching some channels that talk about the different components of a network. This is in AWS it's similar to the other to the general components of a network, but it's more focused on the AWS services. Now, first thing we have to do is create a VPC. That's the first thing that we have to do, a virtual private cloud. So for that, there are multiple ways that you can do that. You can do it by clicking here on your VPCs, right? In this case, I already have one. And I have the default one, because when you create an account, you're always going to see a default VPC created along with account, right? Now you have here in this sidebar, we have VPC subnets, route table, internet gateways. We have different components that we may use or we may not use when we deploy resources. But today, we're going to create the ones that we're going to use for the 3-tier web app. And the first thing we're going to do is create a VPC. We click here in this button that says create VPC. And this is the wizard to create a VPC. So we're going to give it a name. Let's say, as we call this the tech show, right? We're going to call it tech show. We'll say VPC, right? It's going to be like an identifier is a name, right? Now we have to decide, and this is when you may have some questions, how many IP addresses we're going to allocate for this VPC. And this is when the CIDR comes in. And the CIDR stands for classless domain inter-domain routing. That's what it stands for, classless inter-domain routing. Basically, you are defining how many IP addresses you're going to allocate for this VPC. And in this case, we're going to use a typical one that everybody uses when they create a VPC for the first time. We're allocating 16, a prefix 16, which means that we are allocating 65,536 IP addresses, right? That's it. That's all we need, right? To create a VPC. Now you can have IPv6 enabled or not, right? In this case, we're now using IPv6. We can use IPv4, right? There's a concept of tenancy that you can have a default or a dedicated. The default is the one that most people use that ensures that the instances or all the resources that are launched in this VPC, they use a tenancy specified at launch, or if you're creating a VPC for outpost privately connectivity. That's another service on AWS, which is for hybrid and edge connectivity, right? Now, a dedicated is a more, I would say, more particular and private one that you can specify as well. But in this case, we're going to use the default one. And as you can see, when we type the name here, it defaults in the tags, which you can use later to identify this VPC. So we create the VPC now. As you can see, it's created for you. And if you have questions, I see that Joe is going to ask. Go ahead, Joy.
Yes, I have a question. I was gonna say, I know there's IPv6 that people can obviously reserve those
Mhm.
blocks. When it comes to 3-tier web app, is it more reasonable for people to start with IPv4 than in the future as they get more familiar with IPv4 and how those type of cider blocks work before they later down the line try out IPv6 when it comes to utilizing those network configurations. What would be your recommendation and suggestions, or from what you've seen in general, when you get started with your journey in the cloud?
Guys, what do you think?
I mean, I have my own personal opinion. I think my personal opinion is
Right. I
obviously
mean,
start
yeah,
IPv4. Then
I-
obviously IPv4 is not going to last forever, but later down the line, you still want to start utilize IPv6. But
right,
it's a good lesson to start with IPv4.
Yeah,
right, right,
I
right.
think
Yeah,
like I think like it's good to have some background about how IPv6 works, right? Like both IPv4 and IPv6, and how you can like probably like migrate from IPv4 to 6, because there is an associated cost to having IPv4 addresses. So
Yep.
that's something you just have to like make sure or put in an account.
right. So, and IPv6 they have 128 bits, and IPv4 they have 32 bits. So it's smaller. But like you said, Joe, is we're running out of IPv4 IPs, so we have to be careful with that. If there's a company that's thinking about having starting to utilize IPv6 in the future, I recommend doing this now. Like open it, keep it open, and then use it when the time comes. But it will be to start with IPv4 first, right? Now, and as you can see here,
Actually, Dineski, before you like continue, maybe just to level set like at a high level, like when it comes to like VPCs, I know it's actually it's called like a virtual private cloud. What would you consider it? Is it more like of your own virtual data center? Like, because a lot of people they're coming from on-prem, and they probably just don't know the concept of like a VPC. So maybe we could kind of a little bit briefly talking about it. And
my understanding of VPC is there is it's a small portion of the AWS cloud that is dedicated for you, because you're creating that, you're selecting the CIDR, the range of IPs that you're going to use, you're selecting your subnets, route tables, you're creating your virtual network for you, right? And a VPC has security as well, that nobody can just come and access it because they want to access it. So it's dedicated for you. It's secure, and it's a small portion of the big AWS network that is created that you create for yourself, right?
so it's like a virtual data center where like it's like logically separated from other networks, right, or other
Yeah,
VPCs, so they
I
they
don't
don't
know.
conflict.
Yeah, I don't know if you call it data center because you're not storing any servers. You're just laying out the the environment for launching those servers, like the network, where you're gonna launch those servers.
Yeah,
But
yeah.
you're not storing it. Maybe I know what you mean, Ezel, but I don't know. I wouldn't
Just,
use data
just,
center.
just to make it simple, I would say it is your networking space, just like
Yeah,
on-prem, right? You create your local area network where you have your CIDR range and all of that. When you are
hmm
on the cloud on AWS, this is your private networking space where you deploy your resources. In this
right,
case, create your web app.
right,
Right.
right. So continuing here, this is recently added to the AWS console. You have the resource map. The resource map gives you a visibility, gives you like an image screenshot of your entire network, how it looks like, right? So in this case, we have a VPC. We don't have any subnets. We have a route table that is created by default, because, like I said, when you create an account, it creates a default VPC for you. It also creates a default internet gateway. It creates a default route table, but you can create your custom route tables and VPCs and NAT gateways and internet gateways, and that's what we're doing today, right? So once you have I would say the container, which is the VPC, right? Let's create the subnets, right? And why? Let me ask you guys, why would I use subnets?
I mean, like, you always want to divide your network, right, into different portions. So having a subnet is having that logical separation between your network.
Right. Segmentation, right?
Yeah.
You want to segment it to make it more organized, right? Remember, in 3-tier web app, we talked about different subnets. We have public subnets, private subnets, and depending on what resource you're launching, either a web server or an application server or maybe a database, you want to choose the right subnet, right? So let's create now a subnet. I will create 2 subnets, right? Because remember, we want to be highly available. We talked about high availability before, right? Remember? So we said that it's better to have 2 different availability zones and launch the servers in those availability zones, like duplicating your resources, so to be more high available, right? So let's create a first subnet. Remember, we launch a subnet in a VPC, so we have to select the VPC. The one that we created now is the text show VPC, so we're gonna select it, and now we're gonna give it a name. I'm gonna call it public subnet 1, just the first one, right? Now we have here, we have to choose a preference. I mean, if you don't choose a preference for the availability zone when you want to launch your resource or you create a subnet, AWS will create it. We just choose it randomly, right? So
Mhm.
we're gonna choose one. We're gonna choose US East 1A. This is the region. US East 1 and A is one availability zone, right? So we're gonna choose it. I don't know if you guys know, but US East 1, which is Northern Virginia, has 6 availability zones, right? Now, this is the VPC CIDR. Now we have to choose the CIDR for our subnet. So I'm going to start with a simple one, which is 10.0.0.0/24. Now, as you can see, it gives you 256 IPs, right? But something interesting is going to happen when I create this subnet. Let me create it now. We are done here. And we created our first subnet, right? Now, notice something here. I'm going to scroll to the right and we see a different number. Why? We saw 256 and now we see 251. How is that possible? Okay.
Reserve
Yeah.
IPs.
So AWS will always take 5 IPs for every single subnet you create. It's going to take the first VPC for the network, not the VPC, the first IP for the network. Is going to take it at 1 for future use. It's going to take 1 for the VPC router. It's going to take 1 for the DNS server, and it's going to take 1, which is the last one, which is usually called the broadcast IP. It's going to take 5. So you have 256. You're going to have 251. You have 1094 or 48. You're going to have 5 less, right? Always remember that. So we have to plan for that when we create the subnets.
That's a
Right.
good point because like sometimes you don't really put that into account, right? When you're trying to create your network, and then you put like a low or like a high CIDR range or a prefix, and then it won't be enough. So let's say if you have 10 servers and you're allocating for just those 10 servers, then you can't add any more, right? So it's kind of a deadlock situation.
It's very important that it's like you say, is when you create a CIDR, you cannot modify it. You have to create another one, right, to extend it. So it's good to have a good plan, an understanding of how many address you would need, or at least a rough estimate before you create your VPC router, CIDR, and also your subnets, right, the CIDR. Okay, let me create another subnet, but this time it's going to be a private one, right? So I'm going to call it private subnet 1. And for those watching, if you want to create another public subnet, you have to do the same thing as I'm doing, or another private subnet, you can do the same. Just repeat what I'm doing here. Now, see what's going to happen now. I'm going to choose the CIDR But now we should have a problem. And here we have a problem. What problem are we having here? This is a very typical problem and a very common one. We have an overlap, right? And subnets, the CIDRs cannot overlap in a subnet, right? So for that, we have to choose one of the bits here, which is the network here, and we have to choose one. That's gonna be another address, right? So remember that every single bit has 255. Every single byte has 255 bits, right? So this is a byte, this is a byte, a byte, a byte, a byte. And this is not a class of networking. So if you guys want to know more about this, you can watch other videos. But for you to understand that we have to have a different bit here in this byte, so there's no overlapping with the subnets, right? So I create this subnet, and there you go. Now I have two subnets. We have a private one and a private one. I have two VPCs here. Let me see. I want to sort this out by name equals tech of the VPC. Okay, so this is I'm going to, let me see what VPC I have here. So I have my demo VPC. I'm going to delete this one. And I'm going
I think it's the bottom two.
Yeah, see, yeah, but I'm going to delete this one so that there's no confusion here. All right. There you go. So now we have these two public one and private one. Those are the ones that we just created, right? But do you guys think that just the word public makes it public? Because I just named it public, but that doesn't mean anything, right?
It's magical. It could be.
Yes.
I'm just playing.
It doesn't mean
Why-
anything.
why
It's just
not?
an identifier, right? It doesn't mean anything, right? So for a subnet to be public, it has to be connected to an internet gateway, right? So an internet gateway is what gives VPC access to the internet, right? Either inbound or outbound, depending on what type of resource you have and what route tables you have, right? So I'm going to create an internet gateway, and I'm going to call it Tech Show Internet Gateway, right? Internet, not internet. Internet gateway. Okay, so I created, but I'm missing one action. I have to connect the VPC with the internet gateway. Otherwise, it won't work, right? The internet gateway has to be connected to the VPC, and this is a one-on-one, one-to-one relationship. One internet gateway can only be connected to one VPC, right? So I'm gonna come here to actions and attach to VPC, and I'm gonna select what VPC I'm attaching it to, and that will be Tech Show. And by the way, there's some misspelling here. Tech should be K, not CK, right? But it doesn't matter. You guys understand, right? So now I have the first step for that public subnet to be public. I already have the internet gateway, but now I have to create a route table. In route table, we have entries and we have routes that allow the traffic to move from one place to another, right? Remember that a default route table is created for me, right? I'm going to delete this one, which I don't need. Well, this one. Okay. This is the default one. It says main. It says yes. It means that it's the default one, right? And I will create a new one, which is going to be attached to the Tech Show VPC. I'm going to create it here. I'm going to call it Tech Show Public Subnet, right? I'm going to connect it to the VPC. It's going to be this one, and create that route table. Now I want you to see our roadmap. Let's see the roadmap now. So the roadmap that we saw before was kind of empty, right? Look now. What do we have now? We have we have our textual VPC. We have two subnets, one private and one public, and this one is connected to the route table by default, the custom one. I'm not the custom one, the default one. But we have to connect the private one, the public one, to the one that we just created. And how do we do that? By adding a route to the route table, right? So let's go back to the route table, which is here, right? And let's first associate it with the subnet. Let's associate it with the subnet. So let me come here. I have a lot of misspellings here. Tell show, what? This is crazy, right? Okay, so let's edit the association with that. So we're gonna select that with the public one, associated, and now we go back to the roadmap. We refresh the page. We see that our public subnet is connected to the text show public subnet. So now we have a
Danielski,
connection. Yes, go
Danielski,
ahead.
I have a question, and I think this
Yeah.
is something the audience would probably,
Mhm,
obviously, in a real life scenario, people would trying to want to get better clarity
mhm.
on. Uh,
Yeah.
have you ever had a scenario where you would have to use multiple route tables in that VPC? And the reason why I'm asking that question is
Mhm,
because in a real world environment, you want
mhm,
to probably isolate different environments. So you probably have a VPC that's for like staging, production. Obviously, you want to do multiple different accounts for that, but you have individuals in the organization that want to probably use one account for maybe, in this case, development and staging, right? How do you isolate? And have you ever seen a scenario where you have multiple route tables that are isolated per the different environments that you have? Have you seen
Yeah.
that in general?
Yeah. I mean, a route table is basically um, like a router, right?
Yep.
A router has a route table. That's part of the router, right? And then it depends. Some people may use the same route table for different subnets, right?
Mhm.
Different accounts, depending. It all depends. It comes down to the routes that you have. Where's the traffic being routed, right? There are certain route tables that are dedicated to a specific environment, right?
Yeah.
Only the traffic can go there, but there are route tables that can use in different environments. It depends. Like in the case here, we can use that public subnet for different subnets. I mean, that route table public one for different subnets. Remember, we have two different subnets in two different availability zones, right? We can use the
Yeah.
same route table if they had the same traffic, right? So I don't know if you guys, Evans and Iso, if you have a different opinion or maybe you want to add to that, but it all comes down, my opinion, to the routes that you have.
Yeah, I think it just goes down to like the networking requirements of like,
Hmm.
and also like how big your enterprise is, right? So if you want to go towards that granular level, you might want to have like multiple route tables for specific subnets or VPC. So it all depends
Hmm.
on your networking requirement, you know. But it's
Right.
good to plan early, something like this.
Yeah.
Yeah.
No, absolutely. I think that's a great answer because I think it all comes back to the individual and their requirements, right?
Right.
What is the requirements of the organization? Because sometimes you do see individuals say, well, we want to use this one account, but we want to isolate the environment, not necessarily production environment, because you don't mix up obviously dev and stage in one account, which production is in, but they still want to mix, but then isolate dev and potentially stage environments or QA environment. But then when it comes to the actual routing of these traffic, they want to utilize maybe one, two, that gets multiple it can get complicated. So you just have to plan that out. And resource mapping, specifically in VPC, I love this because I'm able to actually visually see where my traffic's flowing. I can actually see where the routes are going. So that's one of the reasons why I wanted to ask that question because I want to bring to the point that people have to plan for these if they're going to use multiple routes for different environments and different workloads. If
Yeah,
it's in the
Yeah.
same VPC.
and to add to that is the overall networking, right? We are talking about the VPC, is all of this that you plan ahead of time before you start doing this, and of course based on the requirement of the specific organization.
Yeah. It can get more complex when you start adding transit gateways, transit gateway policy tables, attachments, and things like that, right? And there's organizations that have share VPCs and share accounts, right? And they use those VPCs and those accounts like for a dedicated purpose, right? And then you have to go through them. The multiple customers that have a share VPC, like something that is like a layer of protection that you have through that VPC to go into the other environments. So and that has to have route tables, right? Route tables are the ones that route the traffic, right? Now, so we're still missing something here. We are missing the connection between the public subnet with the tech show internet gateway. Let me tell you something. So far, everything that we've done, we haven't spent a cent. VPC is free of charge, right? Except when we start adding other resources like a NAT gateway. A NAT gateway it's not free, so you're gonna pay for that, right? So for those at home following me or doing what I'm doing, be careful. Because if you created a NAT gateway, maybe if you created and deleted immediately after you're finished, probably you're not charged. But if you leave it running or leave it there, you're gonna get a surprising bill for sure.
Danieski, you
Yeah.
brought up two terms, or you brought up a term that I think I want to poke at a little bit
Mhm.
and make sure the audience are aware of. You said NAT
Mhm.
gateway. A lot of
Mhm.
times people get confused with NAT gateways and internet gateways, but then also get confused with NAT instances.
Okay.
Obviously, we want to provide that clarity to the audience here. When is it? Obviously, we've seen so far that we want to use internet gateways to make sure our public subnets have access to the internet. And if we need to have access to outbound traffic for our private, then be sure we want to use
hmm
NAT gateways. How does NAT instances, or how does that come in play here?
So both they they uh they do their functions, right?
Yep.
Which is doing NAT functions, right? NAT network address translation, right? They both translates. They both translate an IP address into a private IP address, or vice versa, and a private IP address into a public one for those resources that need internet access and they're private, right? But a NAT instance is basically a server, right? That has NAT functionality and is not highly available by default. So it means
Yep.
that if the server breaks, everything breaks. I mean, all the purpose of the NAT doesn't work anymore. The NAT functionality doesn't work anymore, right?
Yeah.
And also another thing is that is not fault tolerant, which a NAT gateway has. So a NAT gateway is highly available by default. It's fault tolerant, right? And it's managed by AWS. So that meaning that it has an internal mechanism that it will kind of be or withstand any failure. So it will continue working, right? Now the bad thing about it is that it's not free. That's one of the cons. And if you want to have that, you have to create one NAT per subnet or per availability zone, right? So
Yep.
that's something that you have to understand as well. Now, a NAT instance, like I said, is an EC2 instance with NAT capability. You have to use auto scaling, or you have to do some sort of mechanism to keep it available, because like any other EC2 instance or any other server, once it breaks everything after it. So at least the functionality that has to do with the NAT gateway, with the NAT thing. So that's
Yeah.
my
And
humble answer.
And I think I wanted to add a little bit to what you said there is that, okay, Internet Gateway gives your subnet traffic access to the internet, right?
Mhm.
So you just made a public subnet and a private subnet. So usually the cases where we use a NAT gateway is let's say you deploy resources right in the private subnet. Those resources do not automatically have access to the internet. Only the resources in the public subnet, right? So if you have those resources in the private subnet for which you want to be able to perform update for which they will need access to the internet. This is where you actually configure a NAT gateway in the public subnet and
The private.
allow them to connect and be able to perform those updates.
Sure.
Just to add to that.
Okay. So let me go ahead now. Connect the public subnet with the internet gateway. So what we have to do for that is go back to the route table. And in the route table, remember that we associated the subnet, is right here, the subnet with the route table. Now what we have to do is add a route, right? Add a route to point to the internet gateway, right? So that's what we have to do now. Go to routes, edit routes, and then we're gonna add a route. So by default, the CIDR of an internet gateway is 0.0.0.0/0, which means every single IP address in the world. Is the internet, right? The land of no man. That's what I call it, right? Because it's just that there's no rules, there's nothing there. It's just it's just
There are some rules. There are
Yeah, but
some rules.
it's I know. There's security that can be utilized, but in the internet, you basically can do whatever you want until you get caught, right? So that's why I call it the land of no one. And then once we have that, we internet the resource that we are pointing to, which is the internet gateway, and we select the internet gateway that we just created. It's this one, right? And we save it, and that's it. We now have an entry, a route pointing to the internet gateway, which is the destination of that route. If we go back to the roadmap and now we refresh the page, we see that our subnet, our public subnet, is connected to our internet gateway, as you can see there, right? So now whatever we launch in this subnet is going to have internet access because it has a connection with the internet gateway, as you guys can see here. I would like to create a NAT gateway and connect it to the public subnet, but I don't know if you guys have more questions. We're almost done with this. So we're gonna launch everything that we need to create a 3D web app. We don't need anything else for now.
I might have a question on this, Danieski,
Yes.
or maybe
Yes.
we can just discuss about it.
Yes.
So I know there's a public subnet, and that's where all the web servers, all the front-facing servers are placed in there. So now in a 3-tier web architecture, you have possibly two private subnets, right? You have a subnet for your applications, and then there's another subnet for your database. Am I correct?
Repeat that again.
Like a private subnet for your database. So you're going to have
Yeah.
two private subnets, right?
Yeah. So yes, we're gonna have two private subnets if you have a database and a standby, a master and a standby one, right? But it comes down to the requirements of the business use case, right?
Right.
There's customers that don't need two databases, basically. They need only one. It depends. So that's something that we have to find out when we talk to our customers, right? Or when you guys talk to your customers as well. Okay, so let's create now a NAT gateway. Remember, NAT gateway, money. Just remember that, right? So let's do it quickly. So we have a NAT gateway, create a NAT gateway. Now, by default, for a NAT gateway, we have to create something called an elastic IP, right? So we have to allocate an elastic IP. And this is an IP that is fixed. Fixed, what do I mean by fixed? When we have a server like an EC2 instance, and we stop the EC2 instance and start the EC2 instance again, we lose our previous IP address, and a new one is allocated for that server. In order for you to keep the same IP address, you have to have an IP address, an elastic one, attached to that server. And by the way, I think the default quota is 5 IP addresses per account for new account. And you're not gonna be charged for the IP address as long as it is attached to a running EC2 instance. Not sure about the second one, but at least the first one is free if it is attached to a running EC2 instance, right? So the first thing that we have to do is, let's go here to EC2 real quickly. I think I can go here and allocate it, but I will have to refresh the page. So let me come here to EC2 and real quickly create an elastic IP. So I go here and under network and security, I click on elastic IP and then I allocate one. So, I mean, we're getting it from the IPv4 address pool, right? And we just allocate it. That's it, as simple as that, right? Now, when we have one IP, this is a simple IP address like any other, but it's called elastic because it will prevail, it will persist in your servers once you attach to them, right? You can release it because remember, if you're not using it, this is like the garbage in your house. If you're not using it, throw it away. In this case, if you're not using it, release it because someone else can use it, right? So don't keep it there. And remember, once you disassociate it from an EC2 instance, you're going to be charged. Remember, you have to keep it attached to a running instance. In this case, it's not attached to a running instance, and we're going to attach it to a NAT gateway. That's why NAT gateway, one of the reasons why NAT gateway is not free, right? So once we have that, let's go back to the NAT gateway, refresh the page, right? And let's give it a gateway, a name, private subnet 1 NAT. Okay, drop down. We have to select it in a public subnet. Remember, NAT gateway has to be deployed in a public subnet, right? In a public subnet, it has to be like a NAT instance as well, right? Not in a private subnet, in a public subnet. So let's do in a public subnet here. Let's find that IP address and let's create it. Now, NAT gateway tends to take a little longer than the other resources. As you can see, it's pending, right? So in the meantime, you guys can ask questions and just to give it some time, right? Before we attach it to the public subnet, right? The private subnet, I'm sorry. But remember, very important, it is deployed, it is created in a public subnet, right? And right there, right then, it's going to translate those public IPs when the traffic comes from the internet into private IPs, so it can communicate with the private resources, or vice versa when it's going. Just in case your servers need updates, patches, you need to go to the internet and get those patches and those updates, right? So use a NAT gateway for that. NAT gateway.
I have a question, Dineski, but maybe we don't have to answer it. Maybe it's just for thought. So
Yeah.
let's say if I have multiple public subnets, would you think it would be ideal to have multiple NAT gateways placed in those subnets, or just one NAT gateway?
You need two. You have to have one NAT gateway in each public subnet of each availability zone, right? So you have to have that. So which increases the cost, right?
Right.
Because you're having two NAT gateways, right? So yeah, that's a way. Now,
yeah, and I
if you
think
have it in one,
just for our viewers, I wanted to also add, I know we answered the question, but the internet gateways, right, it uses for both inbound and outbound traffic, but the NAT gateway is only used for outbound traffic. I think it's worth specifying as well.
Right. So it's only to go out to the internet, right?
Yeah, and if you think about it, that's like for security reasons, right? You don't want your
Sure.
traffic coming, like someone trying to connect to your EC2 instance, right, in your private subnet.
Right.
That's correct. Yeah.
Right. Yep. That's the way it is. It's still creating here.
It gives you another
Oh,
layer.
it's available.
Ready.
It's available. Yeah.
Yeah.
It's available now. So let's go ahead and let's go to a route table and create a private route table. Right? We did a private route table. We have a public one. We did a private one. So private subnet 1 route table. Okay, it's going to be created in the VPC in my tech show VPC. Now we have that one, just like we did before, associated with a subnet, edit subnet association. We're going to select the private one, right? And okay. And now, if we take a look at the roadmap, let me see here the roadmap. Where's the roadmap? VPC roadmap. So we have a private subnet connected to a private route table, as you can see there. And now we're going to connect it to a private network. How do we do that? Exactly as we did with the internet gateway. We have to go to the route table. We have to add an entry that points to the NAT gateway, and that's going to be connected. Let's do it. So we go back to the route table, the private one, which is here. We take a look at the routes. We edit the route, and then we add the route. We say same thing. Remember that when it goes from the private resources to the internet, is the same destination, the internet, right? So it has to be 0.0.0.0/0. But now the resource is going to be different. It's not going to be the internet gateway. It's going to be the NAT gateway. So we're going to select the NAT gateway, the resource ID, which is this one here, and we save it. And now we see we have a NAT gateway route to a destination, which is the NAT gateway, right? And if we go back to the roadmap, I like to see the roadmap, guys, because it gives you like an X-ray of your connections, right? And here we have the roadmap, and we have the connection here, as you can see, right? And the private subnet connected to this one, and the public connected to this one. Now we are ready to deploy public resources and private resources in these subnets, right? So that's all for the demo. In another demo, we'll continue launching the resources, but this is for now just the environment, the network environment to launch these resources. And I have to move fast with the NAT gateway, okay? Don't forget that.
Yeah, and I think this demo is really good because it put everything we've been talking about into clear perspective here. All right, so we talk about the different layers of the three-tier three-tier app, and then we have the public subnet, we have the private subnet. We said that in the private subnet, like we mentioned 2 weeks ago, that we deploy our databases. Definitely our databases, we don't want to put it off to public, so definitely put it in the private subnet. And then for our front end, for our servers, we deploy those into the public subnet. And like you mentioned, like you show in the routes, they have direct access to the internet. And then for those resources that we deploy in the private subnets, such as the database or any other resources, if they need to perform updates, right, they can perform that outbound connection to the NAT gateway and be able to perform those updates. So yeah, I think this is
No, right on.
Awesome.
This is an excellent demo. Like, it clearly shows like how you can configure your own network and on the cloud specifically, right? So I think it's a good step, a good starting step.
And it's only a portion of what we can learn and know about VPC, right?
Yeah.
So this is the VPC dashboard. See how many things you can find here, right? And here you can see the resource map, the CIDRs. This is the CIDR that I created for my VPC, the flow logs, just in case you have some security there. You want to control the traffic that comes into the VPC, right? So you have the flow logs, you have the logs that you can check, right? You can query with other services in AWS, and integration with CloudWatch, just in case you want to monitor the internet traffic. So many things that we can do here. I mean, we could spend the whole night trying to demo this, right? But we just wanted to give you a taste, a glimpse of what you can do to launch resources in AWS, just like Evans explained, either public ones or private ones. Back to you, Joel.
I would say, like to Dines's point, we can spend, man, an hour, 2, 3, all night walking through the various different components of VPC. Like you saying that makes me think, oh, can we discuss the network firewall protection on this VPC? That's an additional thing we can do, right? Oh, can we talk about how this can be integrated or connected to a VPN? Like, there's so many things that we can keep on talking about that we might not have the time for today. But in regards to 3.2 web app, this is the start. You're building these foundational blocks to get us to start deploying our applications on these servers, to a server they're going to deploy on these VPC in the next demo. So look forward to that coming up. Evans did a great job summarizing the holistic thing that we had done today. Danieski, great demo. Great question today, team. I think the audience that are going to watch this, whether it's watching right now or watching later down the line in our other videos, we're going to learn a tremendous ton about building a foundational block for our 3.2 web app here. With that being said, we appreciate you guys as always. One fun thing I always like to do at the end of these meetings is please, please, please make sure that you always like, comment, follow our YouTube channel, our LinkedIn page. We recently hit that 160 mark on our LinkedIn. We appreciate the support that you guys are giving us. We are obviously looking to progress and make these videos and live streams a lot more better. And if there's any comments, any suggestions, any feedback, we take those feedback at heart and we make sure that we improve on those. So with that being said, thank you for supporting us. Thank you for watching this. We will see you guys next week with the part 2 of the 3.2 web app demo series.